Welcome back to 3D Decode. In this session, we'll cover nozzle loads and piping flexibility, a crucial design check that every package and piping engineer must understand. Excess loads at equipment nozzles can cause misalignment, seal and bearing failures, casing distortion, vibration, and warranty issues. Your job as a designer is to keep loads within allowable limits and ensure piping flexibility. Let's dive in. Why this matters. Excess pipe loads and moments at equipment nozzles create serious problems: misalignment, seal and bearing damage, casing distortion, high vibration, warranty violations. That's why flexibility analysis is mandatory in rotating equipment packages. Standards: who does what? ASME B31.3 governs pipe stress, flexibility, and load cases. API 610, API 617 define allowable nozzle loads for pumps and compressors. API 686 covers installation and piping philosophy around rotating machines. Sources of nozzle load: sustained loads, weight of pipe, valves, fluids, pressure, thrust, bellows. Thermal loads: expansion, contraction, differential growth of skid versus pipe rack. Occasional loads: seismic, wind, relief valve thrust, slugging, pulsation in compressor lines. Keeping loads low: layout and support tactics. Add flexibility with small offsets or loops. Avoid long straight runs. Place the first support near the nozzle, typically 2 to 4 times pipe OD away. Use rest supports to control sag but still allow axial growth. Guides, then stops. Guides to control lateral wander, stops further out to control growth. Springs for hot lines with vertical movement. Expansion joints, last resort, require anchors and guides per manufacturer. Suction lines, always short, straight, well supported, and free of elbows close to the nozzle. How checks are done. API and vendors provide allowable nozzle forces and moments: FX, FI, FZ, MX, MI, MZ. You'll 1. Get operating loads from pipe stress software, Caesar 2, AutoPipe. 2. Normalize each load to the allowable, e.g. FX all. 3. Apply interaction equation. U equal Fx, where F1x squared 2 plus F2 F squared F 2 plus WMX F squared 2 plus MZ Q 1.0. Pumps, API 610, are usually more sensitive than compressors, API 617. Treat suction nozzles with extra care. Strict flexibility workflow, quick recipe, inputs, line list, nozzle coordinates, allowable load table, support philosophy, seismic wind data. Model, routing, valves, reducers, supports, equipment stiffness if available. Load cases, sus equals weight plus pressure. EXP equal thermal expansion, OPSUS. OCC equals wind seismic relief. Check. Code stresses B31.3, nozzle loads, API 610, 6 and 17. Iterate, adjust supports, add guides, stops, insert offsets, loops, or springs. Document, nozzle load report, unity check, support sketch. Mini example illustration. Suppose vendor allowables are FXA equals 12 kilonewton, FZA equals 10 kilonewton, MXA 2.5 kilonewton minors, MyA equals 3.0 kilonewton, MZA equals 2.5 kilonewton. Your model gives FX equals 6, FY equals 7, FZ equals 4 kilonewton, MX equals 1.1, My 1.2, MZ 0.9 kilonewton ratios. Ratios 0.60, 0.5, 0.4, 0.36. Unity check equals sum of squares. 1.17, fail. Fixes: move first support slightly away, change to rest guide, add small offset near nozzle, or place a line stop further out. Rerun until U 1.0. Common mistakes and fast fixes: hard anchor at nozzle, move it away, use guide instead. Long straight run, add an offset or loop. Heavy valve near nozzle, shift outboard, add support. Hot vertical drop at nozzle, spring support under drop leg. Expansion joint too close, move EJ away, add anchors guides for thrust control. Mini quiz. 1. Which code governs pipe stress flexibility? 2. Name 2 categories of loads that create nozzle loads. 3. What's the typical first support strategy near rotating equipment nozzles? 4. What does the unity check equation tell you? Practical tasks, hands-on. Here are some exercises to practice today. Nozzle load check sheet. Create 1 tab per nozzle with vendor API allowables, your loads moments, ratios, and unity check. Paper flexibility sketch. Draw your suction line. Place supports 2 to 4D from nozzle as rest plus guide. Add midspan guide and line stop. Add a small offset to relieve thermal loads. Stress model iteration list. Write down 3 design tweaks you'd try first if U 1.0 and explain why. Interview Q&A. Q. How do you reduce excessive nozzle moments without changing equipment? A. Add offsets or loops. Adjust supports, add guides or line stops, or use springs. Q. Why avoid anchors at equipment nozzles? A. They force thermal growth into the casing, causing distortion and misalignment. What's the difference between sus and EXP load cases? S equals sustained, weight plus pressure. EXP equals thermal expansion, OPE CUS. Q. Why are pump suction nozzles especially sensitive? A. Because excess loads affect hydraulic stability and alignment, causing seal failure and vibration. Q. When would you use an expansion joint? A. Only when routing is constrained, with proper anchors, guides, and thrust control. And that's it for today's session on nozzle loads and piping flexibility. If you found this breakdown helpful, don't forget to like, share, and subscribe to 3D Decode for more engineering deep dives. See you in the next video.